Okay, good day grade 12, good day or good evening. That is depending on the time you're watching this video. So in the following tutorial video series, I'll be going through questions or rather sequences and series questions. And majority of the questions that I'll be going through here, it's questions that were posted by our subscribers either on our platform or on our public WhatsApp group. And in the event that maybe you've got an alternative solution that you feel is much shorter, you're more than welcome to share with us. You can share with us on our WhatsApp page, or you can just send your answer on the chat section of this video. With that said, let's get started. So question number 1. Given the sequence 7, 12, and 17, write down the next two terms of the sequence. So we need to first determine what kind of a sequence this is. So by inspection, you should notice that the difference between two successive terms here is 5. So to get the next term, I can just say 17 plus 5, which gives me 22. And then for the second question, determine the general term of the sequence in the form of nth term is equals to an plus b. So I need to find the nth term that defines this series. And the formula for that, for linear patterns, it's given by a plus n minus 1 times the difference. Our value of a is the first term, and then the difference is equals to the value 5. So I can say 7 plus, I will multiply 5 into n minus 1. I will therefore have 5n minus 5. So the final nth term is given by 5n plus 2. And then the third question, determine if 12 to the power 5 will be a term in the above sequence. So we're given a value and we are asked to verify whether this value will be part of our sequence. So to verify that, we can just say, let's say at some n, some value n, we've got the value 12 to the power 5. And we equate that to our general nth term, 5n plus 2. And the moment we get like a whole number, let's say maybe we get n is equals to 39. And once we take this value 39 and substitute here, and we do get a value that is equivalent to this, that means, yeah, that value is part of our sequence. But the moment we get something like n is equals to, let's say, 60, 61 point, there's a likelihood that this value is never part of our sequence, no matter how close the value we get once we substitute this decimal value. So let us solve for n so that we get our index, and we need to verify that index. So this is just, we'll transpose, let's say 12 to the power 5 minus 2 is equals to 5n. Okay, the difference of 12 to the power 5 minus 2. And then, okay, let me just write the difference. 248, 830 is equals to 5n. Then I'll divide both sides by 5. Okay, I'll write my n is equals to, divide by 5. I'm getting 49,766. So let us check whether that index does give us a value that is equals to 12 to the power 5. 5 answer plus 2. And let me just say that value minus 12 to the power 5. Yeah, so indeed, yeah, this value it is part of our sequence. and we get that value at this index. So yes, this is true. And then the fourth question, explain why any positive number ending with a 2 will form part of the sequence. Okay, so to frame my answer for this question, how I would approach this, I would look at my general nth term, right? And they said any positive number ending with a 2. So looking at my general nth term is given by 5n plus 2. How I can frame my answer here, I can say given my general nth term, the part where I have 5n, I can create any even number with that, so long as my n is greater than 0. I can create any even number. So for example, I can have 1,000, I can have 100, 200, 500, and on that even number I add the value 2. So mathematically, I'm not sure how you can write that down, but that's just my thought process. And I'm really interested to hear how you guys would answer this question. So just in the comment section, please send through your answers for question number 4.1.4. Why is it that any positive number ending with a 2 will form part of the sequence? I've shared mine. Okay, and then question number 4.2. Given the sequence 3, 9, 17, 27, write down the value of the next term of the sequence. So first we need to determine what kind of a pattern this is. Okay, so we are given the value 3, 9, 17, 27. Let's first determine the differences between our successive terms. The difference between 9 and 3, it's the value 6. Between 17 and 9, that is 8. Between, okay, that is 10. So obviously this is not a linear pattern. The difference is not constant. So let's find the second difference. I'm now thinking this is a quadratic. So the difference here is 2, the difference here is 2. So yeah, this is a quadratic number pattern. So I'm expecting the difference here to be 12. So I will therefore say 27 plus 12, I will get 39. Because notice that the first difference of a quadratic number pattern is always a linear pattern, and the second difference is constant. So this information does verify that this is a quadratic number pattern. And then the second question, determine an expression for the nth term of the sequence. Okay, so we are just finding the nth term of a quadratic number pattern. We can say 2a is equals to a, and then this will be 3a plus b is equals to that, and then we have a plus b plus c. Yeah, this is just the standard way of how we find our variables a, b, and c. an square plus bn plus c. So currently our missing variables, it's a, b, and c. So the first equation that I will solve for, it's this one. We have got 2a is equals to a. So to simplify that, my value of a is just 1. And then the second equation, which is 3a plus b, is equals to a 6. So I will have my 3 into 1 plus b is equals to a 6. So the value b is equals to 6 minus 3, which is just 3. And then the third equation, a plus b plus c is equals to 3. I will have, let me just say, c is equals to 3 minus a, which is just minus 1, minus b, which is a minus 3. Is it? So the value c is equals to a negative 1. Therefore, the general nth term of this pattern is nth term n square plus 3n minus 1. And then the third question, calculate the value of the first term that is greater than 269. Okay, let me create some space here. So for this quadratic number pattern, at which index, okay, not which index, which value is greater than 269? So they are not looking for the index, but rather they want to know the value that follows 269. So we can construct an inequality equation, right? We already have our nth term there, so we can say n square plus 3n minus 1 is greater than 269. So we'll solve for this and we'll find our roots of n, and those roots of n will tell us the index at which index we may find this equation is greater than, okay, let's simplify this first. So I will just say n squared plus 3n. So I'll take my 269 on the left. I will have minus 270. And I just need to find my factors here, greater than 0. So n. Plus and minus, I will use my quadratic formula. Yeah, can't factorize such large numbers. So using my quadratic formula, so my factors is n is a positive 15 and n is a negative 18. So therefore we have n negative 18 or n positive 15. And then I will take these two indexes, or rather, and I'll just select the one that is that's likely to be correct, the positive index. So I will say n square, which is in this case 15 square, 15 square plus 3 into 15 minus 1. Okay, that means at my n is equals to 15, I get that value 269. So now the next index, that's just n is equals to 16. So I will substitute my n is equals to 16 into my nth term, and I'm getting the value 303. So the first value that is bigger than 269, it's 303. And this value it's found at index is equals to 16. Okay, now moving on to another question, question 4.3, which is part 3 of this question. Remove that. 4.3, a quadratic pattern has a second term equal to 6, a third term equals to 2, and a fifth term equals to minus 18. Okay, let me write this down, because we are given just random points. Let's say the first term is not given, so I'll say that is x, and then the second term I'm told it's equals to 6, and the third term is equals to 2, and the fifth term is equals to minus 18. So I'll say the fourth is y, and then the fifth is minus 18. and I'm told that this is a quadratic number pattern. So obviously I need to find my first difference. Okay, that's the first question. In fact, 4.3.1, calculate the second difference of the pattern. Okay, we want the second difference. Besides, anyway, we were going to do this because we are working with variables. So let's find the first difference. I will say 6 minus x. Let me show that with my arrows. And then 2 minus 6, that's a minus 4. And then y minus 2. And then I will have minus 18 minus y. And then the second difference, which is what they want. Okay, I should not have done that, because okay, so minus 18 minus y plus 2. I will have a negative 2y, so minus 16. Please write this, maybe if ever you're not following correctly, please write this on your side, because what I'm doing here, I'm just or rather I'm cutting corners because I don't have plenty of space. So please write this down, like, so that you exactly see how I found minus 16, if in case you are not following. And then y minus 2 minus minus 4. So I will have y plus 2. And then minus 4 minus 6. This will be a minus 10. Minus x. This will be a plus x. So this is my second difference. However, it's most likely that they want me to present this with numbers rather than variables. So first difference. So what I will do to solve for my second difference is, we know that the second difference of a quadratic number pattern is constant. And with that said, I'm expecting this value minus 10 plus x to be equal to y plus 2. And similarly, I'm expecting y plus 2 to be equal to minus 2y minus 16. And to solve, to get like a whole number for my second difference, let me work with this equation, because in this case I've got only one variable, that is an unknown, which is y. So I need to solve for y here, and once I know what my value of y is, I can find what my second difference is. So I'll transpose 2y to the left. I will have 3y is equals to minus 16 minus 2, which is negative 18. Therefore, my value of y is equals to a negative 6. And I can say the second difference is equals to, I'll substitute my minus 6 into this equation. Even this one is fine, but I'll choose the simplest one. So I'll have minus 6 plus 2. The second difference is equals to a minus 4. So the second difference is minus 4. Now, the following question, calculate the first term. Okay, what is the first term? Which is, in this case, we named that to be x. So they want to know what is the first term, and that's just 3 marks. Okay, let's work upwards, right? We know that this minus 10, this right here, minus 10 plus x is equals to a negative 4. So we can solve for x. So x is equals to minus 4 plus 10. Therefore, x is equals to a positive 6. So that means for our number pattern, we've got something like 6, 6, 2. Then if you want, you can find what y is, minus 18. Yeah, it looks weird, right? But yeah, that is our first term. It's the value 6. If you want, you can just go ahead and find your nth term of this number pattern, an squared plus bn plus c. And once you have your nth term and you substitute n is equals to 1, you will definitely find 6. And if you substitute n is equals to 2, you will again find 6. So yeah, I know it is weird. 6, 6, the first two terms. And then the last question now. Okay, we are given a sigma notation. Calculate the sum of 3k minus 1, where k is 0 to 3. So we just need to find the sum of this number pattern. Let's first determine the total, or rather, do we need to? Okay, just for the sake of good practice, let's try and see how many times do we have here. We'll say the upper bound minus the lower bound, then plus 1. And that is 3 minus 0 plus 1. So in total, we've got 4 terms for this. Or rather, we are adding 4 terms. And what we normally do with sigma notations like this, let us first find at least the first 3 terms, so that we can find our value of a and we get a sense of this number pattern, whether it is linear or geometric. But by inspection, you should see that this is a linear pattern. So I'll substitute my k equals to 0 here. So I will have 3 into 0, that is just 0, minus 1, the first term. And then k1, 3 into 1 minus 1, I'll get a 2. 3 into 2, 6 minus 1, that's just a 5. And then it continues until 3n minus 1. So my a is equals to a minus 1. And then the difference. So here I'm just jumping the gun. So this is a linear pattern. So we need to know what the difference is. The difference in this case is just the value 3. And then we can use the formula to find the sum of a linear number pattern, which is given by s sub of n divided by 2 into 2a plus n minus 1 times the common difference. So do you know? Oh, we do know our value of n, which is total number of terms 4, and then the first term and the difference. So we have all of that. Now we can just substitute into our formula to find what the sum is. We've got 4 divided by 2, then 2 into minus 1 plus, what is n? That's 4 minus 1. So in total it's 3, and then the common difference is again 3. And then I'll go to my calculator. So I'm getting the value, or rather the sum is equals to a 14. Okay. And now question number 3. Okay, let me move this. Let's move this. Determine the 5th term of the geometric sequence of which the 8th term is 6 and the 12th term is 14. Okay, so we have a geometric sequence, right? And the general nth term of a geometric sequence is defined by nth term a r to the power n minus 1. And in this case, we are given our eighth term. Eighth term, we are told that it is the value 6. Okay, let me just say 6 is equals to AR. So I'll say n minus 1, which is 6 minus 1. No, man. The eighth term, n is equals to 8. So I need to say 8 minus 1. I'll get a 7. And for the 12th term, which tells me n is equals to 12, we've got 14 is equals to a r to the power 12 minus 1. I'll get a 11. And what I need to find is the 5th term. Okay, I'll say that is x is equals to a r to the power 4. So what I will do in this case, I'll find the ratio of the two given terms. So I'll say the ratio of 8th term and the 12th term. So I will have 6 divided by 14 is equals to AR to the power 7 divided by AR to the power 11. Now let me simplify this. In this case, we'll have 3 divided by 7. And then our A's cancels here. And the R's will cancel. However, in the denominator, I have R to the power 4. And in this case, I'm trying to solve for R so that I find what my R is for this geometric sequence. So we can just invert the two. You can say R to the power 4 is equals to 7 divided by 3. And then I can take the 4th root. So the 4th root of that so this is my value of R. What else do we have missing? Our first term is missing here. So I can substitute my value of R into either the first or the second to find what my A is. And once I have my A and my R, I can now determine what my value of X is. So I'll use this, I'll use term number 8 to find what A is. So I can rewrite this and say A is equals to 6 divided by R to the power 7. What am I doing? Oh, okay, yeah, I'll have a hairy looking equation because okay, yeah, this requires space. But anyway, let me just go ahead and say this is equals to 6 divided by R to the power 7. And I know what my R is, even though it looks very, yeah, 4th root. So I can say this is 6 multiplied by, let's say, R 4th root. Hey, I hate that, eh? Let me just rewrite this as 7 divided by 3. And then again multiply by just 7. So this is our value of A. And then it's now, let's say, this is just the 7th root. Okay, we can say 7 divided by 3. And this is our value of A. Yeah, doesn't look nice, eh? And now to solve for X, We know what a is, which is this value multiplied by our value of r to the power 4. You should get your x. Let me just do it. So a is 6 divided by 7 divided by 3 raised to the power 7 over 4. Then I'll multiply this by my r. And my r, yeah, it's that hairy looking thing there, which is 7 divided by 3. And then I can find the difference of my exponents. Let's just say a quarter minus 7 divided by 4. Let's say negative 6 divided by 4. So at least we are getting, we can simplify that, minus 3 over 2. So the first term, which is x, is defined by, oh, I still have 6. So it's 6 divided by 7 over 3 raised to the power 3 halves, 3 over 2. And this is the value of, not the first term. I've been making a mistake. It's the fifth term. I'm sorry, I've been saying the first term. X is the fifth term. So the fifth term, it's this value right here. This is t sub 5.